And this is another crazy power, work, and time thing, right? So ultimately we've got power is work divided by time, work is force times distance, and then force is going to be, in the case of lifting, is mg, in the case of dragging something, which is the other type of problem you'll see here, u times m times g, okay? In this case, we're lifting the thing, so we're not going to be dragging the thing, right? Let's see, what is the minimum power rating if it's to lift a 560 kilogram elevator 35 meters in 78 seconds, right? So the force is going to be 560 times 9.81, assuming it's not like accelerating it, right? So the force is a lot of force, 5493.6. Right, the work that we do then is going to be, we're lifting at 35 meters, so force times distance is 5493.6 newtons times 35 meters. So times 35, that's going to be a big number. That is, wow, that is 192,276 joules of work. And then power is going to be work divided by time, right? So that's going to be 192,276 divided by 78. Divided by 78. Okay, here we go. 2465. 65.07 watts. Watts. Sorry. Okay, so there would be 2470 watts. Now, some people looking at this would just say, okay, this is obviously what we're going to do is we're going to just say that that's mgh over t, right? And then you could have just done this in one step here, right? Right, you could have just said 56.5 times 9.81 times 35 divided by 78, right? And then without doing this step, and this step, and this step, right? You could have just done it all in one swell swoop and gotten the same thing. The reason why it says minimum power, right, is that certainly nothing. This is what the actual work is. If the work goes to only lifting that thing, right? Of course, there'd be air friction and all kinds of friction, and so you'd actually do more work than this. But certainly, without disobeying conservation of energy, you couldn't have less power than this do that, right?